Dear ladies and gentlemen, I am very pleased to welcome you on a lecture of Professor Siciliano. Maybe you don't know him, but will you know him now? He is one of the most important person in robotics, and he is very interesting researcher, and I hope you will enjoy his lecture. But at this moment, we need to say that this lecture is the part of one big project. It is called Reindustrialization of European Union. As you can see here, Slovakia will hold presidency of European Union, and there will be a big event when probably 1,000 people will come to this conference. So you are welcomed. To say something about reindustrialization, there is a short video, and after we will come to the lecture, okay? Thank you at this moment. I hope our technician, Peťo, can you please play the video? Oh, yes. At this moment, the another part, and very good time to see some experts from the IoT. Maybe you know the IoT is another part of the concept of Industry 4.0. There will be some event about this, and it is called IoT Expo. It is organized by the French Embassy here in Slovakia, and I will give a word to representative of French Embassy.
Thank you very much. So the IoT Expo Bratislava 2016 will happen in Bratislava in the Austria Trend Hotel during 7th and 8th of July. So you are all welcome to attend this event, which is completely free of charge and open. So you can just register as a professional, but also as a private participant. So it is under the framework of the Slovak presidency of the EU. It is to talk, of course, about innovation, some parts about robotics. It will gather actually some startups from France, but also the V4 countries, as to say Hungary, Czech Republic, Slovakia, and Poland, and also bigger companies, research centers, business angels, venture capitalists. So maybe as a professor or as a student, you can come and see the discussion, attend the roundtables. We also have for the professionals some business-to-business meetings where you're able to meet all the professionals about the Internet of Things of the V4 countries plus France. So the organizers are the French Embassy in Slovakia, but also the other French embassies in the V4 countries. We are helped by the French-Slovak Chamber of Commerce and the French Institute. To have all the information, you can visit the website. You have the QR code on our roll-up. And you can also register on the website on the registration and contact page. You have a very simple form where you can fill out all your information and you will be registered. If you have any question, you can ask us, and you also on the website you have some email addresses on which you can email and ask all the questions you want about the IoT Expo Bratislava 2016. Thank you very much.
So thank you, and now for the lecture. I am very pleased to introduce Professor Siciliano. He is a well-known researcher. I don't want to say many words about him because we will be there till another morning. But as you can see, there are a lot of books. We call them Bible of Robotics. I hope all of you know them. And now I will give him a word, and I hope you will enjoy this lecture.
Thank you very much. Is it working? Can you hear me? Right, check, yeah, it's working. I think it's working now. Yeah, perfect, thank you. Could we turn off this first line of light to make, I hope you don't fall asleep then. Yeah, just this light near the screen, I think. Okay. No, maybe then people fall asleep. No. Ideally, it would be to have some light in the back. Yeah, I think this is good. This is good, I think. Yeah. I don't like to be up on the stage because, I like to be among you, with you, so that I'll be talking for about 1 hour, but feel free to interrupt me anytime. If you're curious about some of the stuff that I will be talking about, just let's try to make this as interactive and as participative as possible. Good afternoon. I come from the Department of Electrical Engineering and Information Technology of the University of Naples, Federico II. I'm also affiliated with a research consortium which is CREATE, and this is the main agency for doing European projects with our university. And here you can find the website from my team, like the PRISMA Lab, which was mentioned. So this afternoon I will be talking about industrial robotics in Europe, and also I'll try to address some of the ongoing challenges and the future prospects, where we seem to go. But before I do this, I wish to introduce my team. As you can see, they knew that I was with you this afternoon, so they are just saying hello, just cheering at you. I have a team of about, let's say, 20-25 people. We are 3 faculty in robotics. It's myself, Luigi Villani, and Vincenzo Lippiello. We are all professors of robotics. Then there are 2 assistant professors, Alberto Finzi and Silvia Rossi, and all the others are postdocs and PhD students from my team. They are also, as you can see from the names, we have an international team because thanks to the generous funding from the European Union, I was able to raise a good deal of money, and I was able also to recruit it, to attract people from abroad to come and work in my team and to do research in Naples. So I have some from France, from Mexico, from Argentina, from Japan, and there are 2 more people joining, one from Korea and another from Turkey, joining my team in the next months. So altogether, we are about 20-25 people in robotics. This is our research portfolio, meaning that those are all active lines of research in my team. I don't have time to just read textually all, those are alphabetically ordered. I was discussing this with a journalist from the Slovak Science magazine before this talk, and she was asking me which are the hottest research topics in which we've been working. And my answer was, it was like twofold. On one hand, I wanted to emphasize that the way we have grown in robotics in my team during the last 30 years or so is from a kind of bottom-up approach. What I mean is that my background is in control. I'm a double E, and I started working when I was just first interested to robotics to work at the lowest level. I mean like control of the motors at the servo level. Then with my PhD thesis, I work at the task level. So just how to command a robot, an industrial robot, in terms of the motion at the end effector, and deal with issues like redundancy, singularities, and so forth. And then little by little, I became interested to using exteroceptive sensors, so like visual and force feedback, and to embed this kind of measurements into the system and to make the robot to interact actively with a partially structured environment. And then we came interested to problem of grasping, manipulation, and then little by little also about other issues like surgical robotics. Aerial robotics is one strong area of research in my team. So, I mean, the research has really expanded. If I think 30 years back in which we were just doing control of nonlinear systems. Now, I think I can define myself and the people in my team experts in robotics more than being experts in control. It's not that I'm denying my roots because I'm a control engineer, but I think robotics is so broad that control is just one ingredient. So you need to have skills in mechanics, electronics, sensing, perception, real-time, computer science, artificial intelligence, and things like this. And actually my team reflects the really interdisciplinary character of what is needed in robotics, because I have people from mechanical engineering, I have people from electronic, and people also from computer science, not even engineers, and people from biomedical. So this makes research more fun to work in a team when you just put together different competencies, different skills. So I will be taking the exercise of going through some of these research topics through the number of projects in which my team has been involved. The first one was an old project which has been fundamental for Europe. Those of you working in robotics, they remember the times of Euron. Euron was a network of excellence which ran from FP5 through FP6. So there were like 2 editions of Euron, and this was European Robotics Research Network that for the first time just brought together different labs in academia working in robotics. And as a European, I'm quite proud of what we achieved, because nowadays you might have read in the media about the National Robotics Initiative, which is promoted by President Obama in the US. Actually, this is one case in which a European model was exported from Europe to US, because the guy who was running Euron was a European brain, Harry Christensen, professor from Aalborg in Denmark, professor at KTH in Stockholm, who moved to the US in 2006 and is director of the Center for Robotics and Intelligent Machines at the Georgia Institute of Technology in Atlanta, Georgia. And he brought our European model of doing research to the US. Because you know that the academic system and the research funding system in the US is very competitive, whereas here you have projects like REinEU2016 in which we cluster, we work together with consortia, we share, whereas there every single university is competing strongly against one another. And now they have this National Robotics Initiative that for the first time is collecting all the skills and all the universities. So it's, as European, I'm kind, because sometimes, and robotics is one field, if you go to Wikipedia, you see that most of the photos of robots in Wikipedia are from Japan. because they are humanoid, anthropomorphic, like maybe, you know, like zoomorphically spine. And this, of course, you know, Japan is at the forefront of robotics technology research. But as European, I don't feel second to a Japanese researcher for what we've been doing in Europe. So it's just, you know, it's the imagery of the people which is involved by having this kind of fancy humanoid robots, whereas maybe in the Western culture, we would be scared one day to deal with the humanoid, you know, with a machine having the same aspect as a human. I mean, these are just some of the issues. So Euron was a pioneer in this respect. Also, I got involved together with a colleague, who is a professor of science philosophy, into a project which was a sort of pioneer at the time. This project was EthicBots, and this is about the ethical issues behind using robotics technology. And these are very important, and actually it's something that people should be really, you know, should be very sensitive, because, I mean, it's not only a static machine like a computer, and we have already developed a sort of addiction toward these devices. You know, like, I think everybody in this room has a smartphone or has a tablet or something. I just dropped in my, believe it or not, intentionally, I don't have a smartphone. I have a classical phone, a blunt phone you can call, because I don't want to be slave of the technology, even though I work on the most advanced technology. It's my freedom, it's my choice not to depend, because I'm spending 16 hours at my laptop, with my computer, and that's enough. I want to be with people. I don't want to be with someone and be virtually, you know, like chatting or just with other people. But, I mean, this is maybe, it's my generation. I'm 56, it's my age. But, of course, you know, my kids think I'm really Jurassic. But we have developed a sort of addiction. I'm telling you this afternoon because, in a way, do we want to have a personal robot one day in our house? And probably we are not so happy that the machine would look like a human. Whereas in the Japanese culture, they are convinced, they are sure that because it's part of their social system and it's part of their Shintoism, their religion, that machines have soul. And then having soul, they must look like humans or like animals. Whereas I should say that even the robot puppet, the robot pets, like for instance Paro, the robot seal, is being used also for therapeutic reasons to deal with elderly people, and also it's been used for helping children suffering from autism, because I mean the machine is useful. So we have to look at the good side, and this project, you know, about the ethical issues, in which we were talking with people, not technicians, not engineers, but people from social sciences, from science philosophy, from ethology, about, I mean, there are also some kind of social and religion issues, whether one day we will trust our kids to be looked after by a robotic babysitter, or maybe our parents to be, or maybe ourselves in 20, 30 years from now, to be given some care by a robotic helper other than a real person. I mean, as a scientist, as a person, I think we should be sensitive to this, because, I mean, compared to computers, to machines, I mean, computers, these are machines with parts in motion. And I mean, if there is a sort of accident, who is going to be liable for this kind of accident? You know, so if we want robots to be like normal electrical appliances in our homes, we should be concerned with this kind of issue. Oh no, I don't want the sound here. So this was the first big research project in which we were involved. As you can see in our logo, FRIENDS. FRIENDS stands for Physical Human-Robot Interaction with Dependability and Safety. But as the logo is suggesting, we want to make a robot to become a friend of human. So other than the typical industrial scenarios in which the robots are used and operated behind fences in secluded areas, the idea is that robots and humans can share the same workspace. And this is one example. This is the humanoid Justin at the DLR, the German Aerospace Agency. We've had a long tradition of cooperation with them. They are one of the best labs in Europe, I have to say. It's like my PhD student at the time is working, is showing a sort of self-collision avoidance techniques between the two arms of the humanoid robot. just to avoid any kind of accidental collision, contact between the two arms. That was only using a skeleton kinematic model, but of course, this was extended also to use exteroceptive sensors. So this is the kind of issues that we looked at in the Friends project. This was the first huge project which I coordinated in FP7, DexSmart. DexSmart was about bimanual manipulation. So it's a robot having 2 arms and 2 hands. And this is how the robot has learned to prepare breakfast directly from human. So in that kind of project, we studied also an approach which is known in the literature as learning from observation. Basically, you can put markers on a human being, and then you can learn the motion directly from the human being, and you can also learn how to prepare all the various movements which are needed to prepare a breakfast. I mentioned aerial robotics. I knew nothing about unmanned aerial systems. Actually, unmanned aerial systems was not the domain of robotics until, I would say, maybe 10 years ago, because typically unmanned aerial systems were used for patrolling areas, for surveillance, for inspection, because you had a kind of flying camera, a flying eye. The idea that they became domain of robotics because not only can we perform some kind of visual inspection, but also we can perform some sort of contact. So we can mount some kind of manipulator on the aerial robot, and also to fly, see, and touch. I was in a company last week in Italy, General Electric oil and gas company, and they are doing inspection and certification of huge heat exchangers. And only the scaffolding to do an inspection cost them €100,000 a year, apart from the danger of this kind of scaffolding. So the idea is to get rid of all this junk and to use some kind of aerial vehicle, some kind of drones, quadcopters, and the inspector can do this comfortably seated, maybe using Oculus or in a kind of VR room, virtual reality room, and to do the inspection, in a kind of more relaxed way. So this is just one example in which robotics technology can be of help. Then we got involved into another project which ended 4 months ago, ARCAS project. ARCAS is a project, as the acronym is suggesting, Aerial Robotic Cooperative Assembly System. So this time the idea is to have not only one aerial robot, but multiple aerial robots, and to pick up some object and to do some kind of manipulation in a cooperative way. So you can do some kind of assembly, also as this video is showing. It's like picking some kind of object and mounting the bar on some other places. So this was another project which was funded by the European Commission. The follow-up project to Friends, so those are more or less kind of historically developed. This is the Safari project, safe and autonomous physical human-aware robot interaction. So this is a lightweight robot by KUKA. I'm sure that those of you working in robotics know this arm. And we developed a skin, tactile sensor, and which is very sensible to the normal forces as well to the tangential forces. And in this case, we can have just safely touching without causing any harm, any damage to the human. And also, since this arm is kinematically redundant, we can also just act in the null space of the Jacobian, for those of you that know kinematics of serial arms, in such a way that we can have a kind of null space impedance motion. So there's a lot that you can do with this kind of advanced industrial systems. Another project in which my team was involved and is still undergoing is the Sherpa project. Sherpa is a project for robot rescuing. So as you can see, you have a kind of hybrid technology. So there is a rover, there's some kind of fixed-wing aircrafts, plus some kind of mini helicopters, plus some kind of micro UAVs, drones. And the idea is to rescue the victims of avalanches in the mountain. It's like a victim of avalanche has can survive for 30 minutes. So the victim must be, if the victim is carrying the proper sensors, of course, otherwise there is no hope. This would be to be rapidly localized, and then the Sherpa, the mountain guide, has to intervene and also to interact with the victim. So we also developing a sort of human-robot interaction device wearing a kind of biokinetic suite in such a way that the Sherpa, without knowing how to program a robot, how to program the drones, can use vocal or gestual command for drones, just to rapidly act and intervene where they have to excavate, to rescue and to free the victim. So this is just another project. So this was Sherpa. Another project in which my team has been involved, which ran from 2009 to 2013, is ECHOR project. ECHOR project is a different project from the normal research project because it was a project about, it's called European Clearinghouse for Open Robotics Development. The main idea was to overcome the typical barriers that are encountered in transferring technology from the research labs to industry for pre-commercialization. In Europe, we've had quite a few successful stories. The arm that I show you, the KUKA lightweight robot, is the outcome of a successful cooperation between DLR, the German Aerospace Agency, and KUKA, the robot manufacturer. But it's German with German. And German with German cannot get European funding, right? Because when you do a European project, you need 3 partners from 3 different countries, from 3 different member states or associated countries. And that's the way to get. So the idea was to have a sort of draconian revolution into the funding system with this ECHOR project. So what we did, we worked as a sort of meta-funding agency. So what we collect, all the stakeholders, all the hardware, firmware and software available by robot manufacturers, and then we put together all the research labs, including small and medium enterprise. I mean, the difficulty of SMEs to enter into the European funding in Europe and anywhere is that a small company with 10 or 12 employees cannot afford investing 2 months of work, 2 months of manpower into a research proposal which has 10% acceptance rate chance, right? So with this, we put together, and so in the end we funded 51 experiments in which the research team from the lab worked hand in hand with the industrial partner, and this was quite successful. And I must say that this kind of mechanism, and also because of this, you could also have one lab and one SME or one company from the same country, because it was not an isolated project, it was just one experiment as part of this big project. We came around, the kind of legal and administrative barriers. I mean, I have to say that my country, Italy, and my city, Naples, has been a kind of school of life. We have grown, and we are so much trained in overcoming a number of obstacles, especially which concern bureaucracy and things like this. So, we are quite creative in this respect. And now this funding system is widely used within the fourth program. Fourth program is the Factory of the Future program, which is the main program to fund manufacturing. Industry 4.0 belongs to this kind of program. So you have to find some ways. That's the fun of being in research, and to be a kind of free thinker and just to create innovative ideas. Another project in which I will be spending more time, so I don't need much to say now, this is just in my general portfolio slide, is European Robotic Challenges. And this is similar to ECHOR in funding small-size experiments. The difference being that in ECHOR, there were like 51 different platforms, different experiments, which was a lot of fun, but also I think was not good for the standardization and for the benchmarking which is needed. I spoke about safe robots earlier, okay? How can you judge whether robot A is safer than robot B, okay? So you need some kind of quantitative measure of safety. And to do this, we need standards. And to achieve standards, we also need to go through benchmarking. So the idea with Euroc is to have 3 pilot platforms, and I'll tell you more because I think it's, this is my most active project right now, in which we are performing and all the teams are using the same platform so that I can judge whether, because there might be a team in Estonia who wants to use the lightweight arm by KUKA available at DLR, and they might have some kind of smarter algorithm than their own team that they have at DLR. And this is, this is the essence of doing European research in a competitive way, allowing benchmarking. So I hope you got the concept behind. So this was Euroc, also a major step from a funding viewpoint, and also in terms of the connections between the research community, which is the private side of research, and the public side of research, which is the European Commission, which is usually funding our project, this was the constitution of the REinEU2016 Association. REinEU2016 Association was an association which gathered all the old members from the Euron academic network and the industries being active already within United Robotics, which is an industrial association, is association of industrial robot manufacturers, and Europe. Europe was European Technology Platform. So the idea of REinEU2016, which was established this is Association Internationale Sans But Lucratif, so it's a non-profit organization based in Brussels, in Belgium, is to put all the stakeholders around the same table: academia, research center, companies, small medium enterprise, experts. Okay, so that's what we achieved. We have now more than 250 members of the association, and also we have an annual event in March, which is the European Robotics Forum, which is different from a normal conference because it's a forum. So it's like workshops, panels, roundtables, no technical session, because that's where Europe meets to discuss about, and also this has a positive influence onto the preparation of the work program for the calls of the European Commission. So it's a neat way to do lobbying with the European Commission in a way that this is done at a community level, not the kind of an individual level that, some guys are smarter than others and things like this. So I think we felt the mission of doing this for the interests of European robotics. Also, there was a coordination action which favored this, REinEU2016 and REinEU, coordination actions in which we've been involved. And then I was discussing this with a journalist earlier. I was, I could say lucky, but it's not a matter of luck because it's quite competitive. I got a grant, an advanced grant from ERC, European Research Council. That's the most competitive kind of funded research in Europe. And also the grants are quite generous because it's 2.5 million grant only for my team, not even for the consortium. And I got this was the only funded robotic proposal in 2012. And don't be surprised because this is a project about dynamic manipulation. What I mean by dynamic manipulation is manipulation of non-rigid objects, like the formal objects. So objects undergoing both elastic and plastic deformation, which is beyond the state of the art, because in manufacturing you don't have many cases like this, and also manipulation in a non-prehensive way. And of course, we were thinking about a number of applications, like for instance for surgical robotics, like tissue organs. But then we said, you know what? I think dissemination is a very important problem. I mean, I think maybe in Europe we don't do the same. I mean, why is the case that the DARPA Robotic Challenge, which is a US thing, has found so much space and so much coverage in European media, I mean, compared to other, I think dissemination, I mean, we should promote what we do, research, in a better way. And then I came along with this kind of almost provocative idea, and we want to make a pizza making robot. The idea is not to replace the job of a chef pizzaiolo whatsoever, that's clear. But everybody, even the non-experts, the public audience, understands the complexity and the dexterity and the agility which is needed to manipulate. I mean, this kind of, this is the stretching of the dough, this is like tossing, and seasoning is easy, and then it's baking. It's also a very nice control problem because you want to rotate the disc of the pizza because the source of fire is only on one side, and you have 2-3 minutes to rotate the pizza in the oven to guarantee the uniform cooking. So this is a metaphor. It's a media expedient, if you wish, but this was quite successful, and actually is that you can't imagine the coverage that just as received. We were on all TV networks because of course it makes the news because the journalists want a story behind. If you do the most advanced research for molecular, for neuroscience, sometimes it's not catching the attention. So it was a way to disseminate robotics brilliantly. At the same time, we're using now this. We have a new center in Naples on surgical robotics. And we're using some of the techniques that we learned with the RODIMAN project for the recognition and modeling of deformable objects like a human organ, also like tissues and skins like this. So it's starting from the pizza also to the human care, if you wish. So is a new project which started about a year ago is AeroArms, which is a continuation of the ARCUS project, and then REinEU2, which is another coordination action which is just following up REinEU is one of the coordination action, and actually we are trying now to promote the challenges and competition more extensively within the European robotics scenario. So these projects all together from FP6 to Horizon 2020 brought to the team a generous funding of which, of course, I'm acknowledging, of 8.5 million euro. That for a team of that size was quite successful record. You know, I don't think that, I mean, there are many teams in Europe that of this size, of course, that got so much funding in 7-8 years from FP6 to Horizon 2020. And so it's like, so we work hard, we work with passion, but then it's very competitive. It's difficult to have, I mean, in FP7, I took part to 7 proposals for IP. You remember IP, integrated projects, it's like the big projects. I took part to 7 proposals, 6 of which were funded. So of course, you know, you have to write a nice proposal, and also you have to team up with the right partners. And of course, you know, there's a sort of, I don't want to say an alliance, because this could be misinterpreted, but of course, if you team up with the good labs, like for instance, I mentioned DLR, Karlsruhe Institute of Technology, TUM, these are in Germany, like KUKA, and then CNRS in France, ETH in Zurich, University of Twente, and University of Sevilla in Spain. So it's like, in a way, you have a kind of kernel of top labs all together, which, you know, we know how to build kind of successful proposal. Of course, I start from scratch, because, you know, I start from nothing, from zero, because I had no funding from European Union until 2005, 2004. But then, you know, just working with passion, I think, you know, the outcome was quite remarkable. So, let me start. Now, this was a kind of wide introduction. I mean, I can speak as long as I never get tired of speaking. It's, so, I mean, just shoot me or stop me when you get enough. I have about 32 slides, so don't be scared. It's not that, also I will show you some nice video to keep you awake in a few minutes. But let me start. Since, you know, I am committed to speak about industrial robotics, let's look at the data, the world statistics, because that's important. I'm in the research field, but I was discussing this with the journalists. I mean, like, do you like working more on industrial robotics, on humanoid robotics, or this kind of, you know, dynamic manipulation? Of course, you know, research is more fun, and working on the forefront of research is more fun. But as a professor, I mean, from one student that starts a PhD, there are at least 10, 15 graduated students. They have to become professional in the field. They have to be good engineers. I always mention this example. I had a smart student, very smart. He wanted to do a PhD. At that time, I was on the move from University of Salerno, where I became a full professor, back to University of Naples. I had no money, no political power. I couldn't get a PhD position for him. So thanks to my networking, I sent him to Spain, to a colleague of mine, and he worked on a PhD on humanoid robotics for 4 years at Universidad Carlos III in Getafe, Madrid, in Spain. He worked there, and after finishing his PhD, he was hired by Ferrari. And he works now in the racing team. He's one of the 100 engineers that goes around the world with the Formula One circuit. You know, he's an engineer of the team. And I tell my students, why do you think he was hired? Because he was good in robotics. He was good on embedded complex systems with mechatronics and a lot of critical components. And then that's why he, as a control engineer, was hired, you know, together with mechanical, electrical, and electronic engineer in the Ferrari racing team. So this is one example of the power of robotics. So it's nice to be able to really train the future generation of scientists, but my primary mission is to really train and to form good engineers, good professionals. So that's why we have to be sensitive to this kind of data about, this is a world report done by the International Federation of Robotics. There are about 1.5 million robots at work worldwide, and 2013, I mean, this, I didn't have time to update the data. I think now we got the data last December, but this has been a very busy period for me, but the new data are along this line. But after the downturn of the economic recession, which was affected the world economy, now, I mean, especially robotics is one field when, you know, just we're going up, we're ramping up again. And this was the most successful year, 2013, for industrial robots since 1961. So the total market amounts to $9.5 billion US, and it was an increase of 12% with respect to the previous year. But this is only 1/3 the size of the potential market of industrial robots, which goes up to nearly $30 billion. The largest markets are Japan, China. China now has passed the US. So it's, which, I mean, like, in fact, like your smartphones are Foxconn in China, you know, just that's where they are manufactured. It's like most of the system. And then, I mean, in terms of the order, you know, they order not 1,000 robots, like Comau, which is the leading robot manufacturing company in Italy. They sell about 1,600 robots a year. And they order from China, if they ever get one, it's about, you know, 10,000, 50,000, 100,000, you know, for as many robots as they need. So it's like, it's a huge market. US, Korea, and Germany, altogether they're covering 70% of the market. I don't know if it's visible, but that's the time history from 2012 to 2017. And this is the most successful field, is automotive industry, electronic, and then motor, chemical, food industry, and others. But I have a better slide in a few minutes. But also, we have a market for non-industrial application. It's still to come compared to the size of the industrial market, but numbers are increasing. And here is a sensitive issue because most of the service robots for professional use are for military applications still. That's why, for instance, DARPA, which is the agency of the Department of Defense in US, is funding all this research. I mean, like, I know that some European teams have taken part to the DARPA Robotic Challenge. I mean, as European, and also with my ethics, with my kind of deontology, I would have not taken part to a competition for robotics if this is funded for military purpose. And actually, this is the case also when we submit proposal to the European Commission, because I don't want the technology to have a bad use of technology, and robotics is one field. You know, we speak a lot about drones. I mean, just, it's not surprised that we can have, you know, I don't want even to think about the wish, but I mean, this kind of, you know, suicide attacks, like criminal attacks, you know, could also be done with this kind of technology. And it's, I mean, this is kind of scaring me and scaring my kids also, that they know their father is working with this kind of advanced technology. So it's something to be quite sensitive about. But service robots for personal domestic use, there are about 2,700,000 robots for domestic applications, and also the field of entertainment. I think you got this. Can you still hear me? Yes. The field of entertainment is also covering a wider and wider market. So, in terms of the market prospects, I like this graph I made a few years ago, just tracing back. You know, we had the analog wave. I remember when we had like the color TV, and I could watch the first World Cup. I think it was in '78 that the first soccer World Cup. No, it's not working. That's the same. What happened? So, maybe the button. I think so. We depend on technology. So, I mean, the TV, the VCR, the analog devices, you know, like color TV, and I mean, every family had a TV, right? I mean, just it's kind of ubiquitous, disappearing technology. Now, after the analog wave, we have the digital wave. We had the first digital wave, PC, and all the digital consumer networks of the second digital wave. Now, if I come to your house, at every house there is a PC. All of you, but me, have a smartphone or a handheld device, you know, and it's taken for granted. You think that we always said, you know, we need it, you know, we're addicted. So the question is whether to this second digital wave, there will be a robotics wave, and some of you have maybe Roomba, which is the vacuum cleaner. It's like, if you wish, that's also a robot. But it's whether we would have some kind of device in our homes, in our schools, in our hospitals, in our social environments that we would really use as a sort of device that we need, you know, just some kind of dependency, addiction. This was a study which was commissioned quite a while ago, but the prospects are actually fulfilled. This was a study with the sources the Japan Robotics Association And this was a study made in 2005, so it's 10 years later. As you can see from the colors at least, that the blue is manufacturing, but more than 2/3 of the market of robotics will be impersonal and service robots. So, and even the big robot manufacturers are thinking about this. Is of course a surgical, but this is still a niche market because Intuitive has all the patents. So it's not the market; it's a market yet to come, if you wish, you know, for surgical robotics. But for rehabilitation, there are a number of applications in which robots will be. So this is a time for the youngster. You know, if you find some venture capitalists, I think, you know, you could. This is a time in which you remember what happened in the middle 80s with the software houses, where they were blooming. The big business was software. Now could be some app for robotic systems, and or don't think about you know, just there will be a market also for middleware and for software in robotics. As this system, you know, we are in the cloud, so I mean, and you can have, you know, there are techniques like deep learning. And this, the chance that this kind of systems could be used on a kind of massive use and become a kind of booming technology. And the fact that although, you know, there's been some kind of disinvestment recently, the fact that a big company like Google Robotics, decided to enter, funded Google Robotics to enter the system, and it's not only the acquire, I mean, in the media, the news was that Google Robotics had acquired, I think, 15, 16 different companies. This is one side of the story. But I know the field, the biggest acquire was not the companies, was the know-how, the brains. What changed the world, in a world populated by robots one day, will still be human beings. So Google has hired the top scientists, the top researchers around the world to work for them. And that's been much more important than acquiring a company or acquiring an algorithm, acquiring technology. And lucky enough, it's this way, you know, just the smartest, the most brilliant brains are the real power of, in a world to be populated by, I'm trying to be a little bit provocative to you, but I think, you know, we have to stimulate this discussion in our social environments. Okay, so from factories to our homes, this is a kind of summarizing the three major areas for robots: industry, field, and service. And those, that's what I said, I have a better slide. So those are the four most successful markets. In industry, most of the market is automotive, second area is chemical, third is electronics, and fourth is food. Then we have field for aerial, space, underwater, search and rescue, and services domestic, edutainment, rehabilitation, and medical. Medical is the most expensive devices, of course, but the diffusion is still small compared to the potential of the field, because only certain types of minimally invasive surgeries, like in urology and gynecology, are done, you know, like prostatectomy or hysterectomy is done, you know, with robot, whereas the potential might be, I mean, also in orthopedics there is a little bit, and then some kind of specific surgery, but I mean, the potential is much wider for what you can gain by using this kind of technology. So this was, what is distinguishing this ideal path of robots from factories to our homes is the increased level of autonomy. So in factories, as I say, they worked in segmented area, whereas, you know, if you go out in the field and if they walk back to our environment, to our homes, you have to increase the level of autonomy. But autonomy is not necessarily a good thing, because autonomy can be dangerous if the system loses control, and you also need some kind of partial autonomy or some kind of shared autonomy between the human beings and the machines. This was a generous mention in the nice introduction, so if you want to learn more about this ideal path of robotics from factories to our homes, yeah, that's, I'm kind of shy to say that this is the Bible, but actually this is, I used to say that I have 3 kids, and this is my 4th child, the handbook, the Springer Handbook of Robotics. I think it's been the biggest professional thing I've done in my life, even more than the textbook or any other of huge European project, because I put so much work and passion into this. And this was a work done with my good friend and the brother, Usama Khatib, from Stanford University, and it gathered 167 experts from around the world to work on the handbook, and this was the first edition, which came out in 2008. Those are the titles of the parts. Basically, there's one level, which is robotics foundations. There's an intermediate level, which concerns with the core knowledge and technology, methodologies and technologies of the field. So it's like mechanics, sensing, perception, manipulation interfaces, mobile and distributed robotics, and those are the application like field and service robotics, human-centered and lifelike robotics. And this was quite successful, because for the first and only time, Springer got the most prestigious award in the publishing, in the scientific publishing. This is called the PROS Award. This is given annually by the American Association of Publishers, and Springer never won this award before. But the biggest surprise was to win not only the award for the category of engineering technology, the biggest surprise also for us as editors of the handbook was to win the PROS Award for excellence in physical sciences and mathematics. And this was not a recognition to Springer, was not a recognition to myself or Osama. This was a recognition to robotics as a science. Because the book that had won the award the year before was a book by Wiley called Molecules and Medicine, just to give an idea of the breadth of the scope. So, I mean, this was really an award to robotics, not an award to the people, to the community that really nurture this kind of growth of science beyond the engineering, beyond the technology. And the good news is that in 2 or 3 months from now, the second edition of the handbook is coming out. So we worked intensively for the last 4 or 5 years. And so as you can see, it's been an expansion, because we went up from those small numbers, which are barely visible here, are the number of chapters in each part. So we have a total of 80 chapters now. We had only 64. And the number of pages has gone up from 1,600 to 2,300. Although probably, I remember that when the handbook came out, as a guy, a friend of mine at UC Berkeley, oh, that's a very nice tool. It's a very nice tool. I mean, just the students in my lab, they use it as a kind of weapon, because if they throw it, you can really, so it's a tool, So that's, I don't know who will buy the real bound volume, although there's a kind of charm, I think, in reading and smelling a real book in the age of e-books. But we wanted to do something new, and then what we have done is also to have multimedia. So you will really like it, including myself, if I rent or if I borrow one of the smartphones of the kind of dismissed smartphones from my kids. There will be a nice app that you can scan a page containing a video, then you will see the video, you will click and you will see the video inside the chapter. So, and there will be a portal. It's not live yet, but this portal will collect 700 videos annexed to the contents of the chapter. So you will have a reference book, a reference tool, but also a video tool. And believe me, we worked so hard, on this. And I want to acknowledge the big contribution by a young soul, a young robotic soul, Thorsten Kröger. He is a postdoc at Stanford University, but also is an engineer at Google Robotics, and luckily enough is one of the brains, European brains, coming back to Europe, because he will be chair of robotics at Karlsruhe Institute of Technology, starting April 1st of next year. So thanks God there's one European that comes back to Europe, and after being successful and after having earned a lot of money in the US, because just like when I heard the salaries at Google Robotics, I felt so poor. I was like, but of course everything is expensive, because if you pay like I think $6,000 for a flat in the Silicon Valley, then everything is relative, right? $6,000 a month as a kind of monthly rent. So you must earn at least 3 times as much, and yes, just of course that's where all the money. So now I think I want the sound. So probably. Okay, because this is something which I think you are filming this, right? Now, I should ask you because this is a premiere for you, because it's not official yet, and it's not yet in the final form. So I will have to ask you not to cut this piece, this next 10 minutes, because it's a video which is a premiere. It's a video that I have edited together with Usama Khatib and Thorsten Kröger, which will be officially released on YouTube everywhere. It will be public, but it will be so only in July. So I have to ask you not to, just, you can film it, but please delete it, because, otherwise it's not a matter of copyright, it's a matter that this is not released yet. And we want to release, in a big event when the handbook will be launched. But since it's very nice, I think I'm going to share with you informally. And I won't be speaking on this so that, you can really cut and as if I never show you this video, okay? So, let's concentrate for the remaining time on this industrial robotics evolution. And we have like these two axes. On the horizontal we have time, on the vertical we have innovation. So the first industrial robots were like basically PC and offline programming. Then in the second generation, as you have seen also from the video, we have like compliant robots in which we have an advanced mechatronics because it's the use of lightweight materials. But the lightweight material is not enough per se. You also need some kind of sensor reaction, based on sensor, and also you need some kind of control for collision avoidance or also dealing with kind of contact situation. So safety is an issue, and I remember before compliant motion became a kind of commercially available, I visited ABB in Västerås in Sweden a few times between 1997 and 1999. And they were keen to introduce compliant motion and force control into their industrial robots, but the main difficulty was programming. Just because for achieving a compliant motion, you need to act on the control gains. So one story is to do this in the lab, because we are the control experts, so we know how to assign a stiff behavior versus a compliant behavior. But a technician cannot do this intuitively, like plug and play. So there's been some progress on allowing simpler and simpler programming and operation of compliant robots. Then if we go to the third robotics wave, I think the big attention nowadays is on mobile manipulation. This is my point of view, which is also shared. It's apart from the fact that you see, like, intentionally, I didn't put robots from the same manufacturer because I don't like wearing a specific hat. So you saw an ABB, you saw an Universal robot, and this is a KUKA robot. And of course, this is like the OmniRob platform with the lightweight, which is one of the most advanced and one of the most expensive robots. I don't know if you have read the news about 3 weeks ago at Hanover Fair. There's been a revolutionary robot presented by a guy who was a researcher at DLR. His name is Sami Haddadin. Sami Haddadin, he was a researcher in the group of Professor Hitzinger at DLR in Germany. And then the way it works in Germany, that, typically in other countries you have to become an assistant professor, an associate professor, then a full professor. In Germany is a Lehrstuhl, chair. So, and you can be chair, you can be like full professor, it's one shot, even when you are young. So that's very good. And Sami was appointed full professor of robotics and mechatronics at the University of Hanover in Germany. And he is also a spin-off company and introduced a very nice robot, which is like the lightweight robot by KUKA. This is a joint venture between his spin-off, DLR and KUKA. And the name of the robot is Franca Emica. You can Google. The nice thing about that robot, the performance is comparable to that of the KUKA lightweight, but the price is much more appealing because it costs less than 10,000 euros. It's 9,900 euro in the basic version, which compared to the 75,000 of the KUKA lightweight, or even the EVA, which is 95,000, the intelligent industrial working assistant. It's kind of interesting, at least for sure for the research labs, but they're planning to sell hundreds and hundreds of units. They've already received them, more than 1,000 orders since it was launched in Hanover. So the world is changing fast. But that's a fixed, that's a ground-based robot. I mean, just most of the research is now on mobile manipulation, in which we want to control not only the motion of the mobile platform, but also the manipulator. And if at all possible, we want to control the overall degrees of freedom at the same time, because we have a highly redundant system, and we have to control this. So we need more intelligence, and again, we need more intuitive operation. So I will... This is a nice video, which I always show to my students in the first class, because this was a precursor of Charlie Chaplin in 1930 as Modern Times. That's what we've been doing, you know, with the videos. We start with a super game each time. I hope we don't get messed up like this by the end of my talk. So, I mean, this is a metaphor of 86 years ago. But do we want a really autonomous machine? This is much closer to reality.
This is our robot.
Okay. It's insensitive, it's deaf, dumb, and blind.
Yes, but it moves with great precision. Now, if it's supposed to drill holes here, I just show it the positions, starting here, 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 and finishing here. The robot remembers the coordinates and repeats the procedure, and that's it.
Whoa, that thing is dangerous. It belongs behind a fence.
Not if it's equipped with an anti-collision system. Huh? And if we give it a soft reaction to touch, besides making it lighter, it wouldn't do any harm even if it did crash into something or someone.
Not bad. So you could actually work safely in the same workspace as the robot.
Right. And because the robot is now so light, you could easily move it from one location to another.
Wow. So, you could just actually carry it across to the shop floor and train it to load the machines. Ah, but wait a second. But for detecting complex parts, this isn't precise enough.
Well, to simplify the programming, the robot could be equipped with a camera or a 3D sensor so that it could detect the exact positions of the workpieces and choose the best one to grip next.
Yes, yes, of course. And then it might even understand spoken orders.
So this is the SME robot project, which ran a few years ago. But I like this video because this is showing how the advanced industrial robot can be used safely in the same workspace with human. And the two actors were using this as a sort of intuitive tool, like using a kind of domestic appliances in a kind of confident, ergonomic, and safe and dependable manner. So that's where we are now. Now, mobile manipulation. No, there's no sound. No worry. So it's like we can keep it off. So this has been accelerated. This is just to show what I mean by mobile manipulation. So, I mean, you have to control the motion of the arm, but also you have some kind of onboard sensors here. You recognize the fixtures where you have to perform some kind of task. So this is like, I think it's one example. I mean, there's one application for aircraft manufacturing in which riveting is still done manually as a technology, because it's considered not to be precise enough with robots. So this is one example in which you need also a mobile manipulator, because you cannot have, dimension of the aircraft is pretty big, so you need a kind of mobile manipulator system. And there have been research teams doing this for mobile manipulation. Also, intuitive operation, as I mentioned. No, let's see. No, wait. I do like this. So, I mean, the possibility of commanding your mobile manipulator through a smartphone, if you ever dare to use one, or just to use the arm as an haptic input device, or the issue here, I think this you also saw in the general video, the issue of scalability. So basically you can command through a sort of master arm, a small robot with a big robot. So those are important issues. So intuitive operation is one issue which plays a fundamental role in the third robotics wave of industrial robots. Then, as I also mentioned when I was kind of surveying those projects like ECORD or UROC, you will see UROC in a while, I think, and this is a general trend, which is also reflected in the work program of the robotics call of Horizon 2020. I mean, there's a lot of emphasis because we might say that in the last 15, 20 years, we have achieved a number of results which have a great potential. But now it's the time to perform use case-driven research and development work. So these are just some examples: shelf logistics, transport parts, unloading machines and putting parts into bins, simple assembly. In almost all cases, all these cases, the novelty is that you want to share the workspace and you want to cooperate with ordinary workers. I visit one of the Fiat Chrysler automobile plants near Naples. I don't have a strong sympathy for that company, for Fiat. And the reason being that Fiat is part of the Agnelli family, and Agnelli is the main family subsidizing Juventus football club, which I really hate. I mean, passion number one is soccer, and there's like, but as a Napolitan, I'm proud to say that the fourth and the fifth generation controllers manufactured by Comau, the C4G and the C5G, they don't have the algorithms developed at Polytechnic of Torino, but all the software that Comau robots use is done by us in southern Italy, in Napoli. So that's, I mean, as a Napolitan roboticist, I'm kind of proud that they adopted our algorithms, and we've been consulting for them for years and years, you know, for Comau manufacturing. So in almost all cases, sharing workspace and cooperating with ordinary workers. So I was telling you the story. I visited with the rector of our university the Fiat plant in Pomigliano d'Arco near Napoli, and I was really impressed, because this looked to me no longer as a car manufacturing plant. Looked like to me like a pharmaceutical plant, because all the workers, I mean, it was very clean, it was not dirty, not noisy, and more importantly, all the sequences of the car parts along the manufacturing chain, where the spatial temporal sequences was comfortably commanded by the workers, by the technicians, in a safe way, without fences. So this was some kind of achievement, and you have to see this at work to really be convinced that the technology is already there, to have the possibility to share the workspace and work in a much more relaxed and safer condition without the danger to be accidentally hit. Although we heard that, I think it was last year, there was a worker which was killed by a robot in a Wolfsburg plant of Volkswagen in Germany. But that was an unfortunate accident because he was doing some kind of repair on the robot. So this was some kind of, but those things happen. But there are a number of use cases in which human work is at danger. I mean, like I mentioned, for instance, the construction field for robotics. I think the statistics in Italy is for sure that every day at least one person get killed just falling from a scaffolding or because of. So why not to use robotics technology then? You know, because this is the possibility of replacing. But let's stick to the manufacturing. So here we need a sound possibly.
solutions to maintain global leadership in products and services. To this end, some of Europe's leading robotics companies and research institutions have formed a consortium aimed at launching the European Robotics Challenges, EUROC. EUROC consists of 3 industry-relevant challenges within the themes of reconfigurable interactive manufacturing cell, shop floor logistics and manipulation, and plant inspection and servicing. Each of the 3 challenges consists of 3 stages of increasing complexity. Stage 1 is the qualifying stage. This includes a simulation test and a matchmaking event, where challengers can team up with end users, technology developers, and system integrators. The 5 highest scoring teams in each challenge will move on to Stage 2. Stage 2 is performed in realistic labs and consists of benchmarking, freestyle, and showcase rounds, before 2 teams per challenge are selected as EUROC finalists. The 3rd and final stage will consist of pilot experiments at end-user sites under real manufacturing conditions. The results will be evaluated by a board of expert judges, which will eventually select one EUROC winner. EUROC presents some excellent benefits to participants, including a pot of €7 million in grant money, the opportunity to test and benchmark their algorithms using the latest hardware at real end-user sites, and incredible networking and business opportunities. The call for challengers will open from April 1st to June 30th, 2014. If instead you are an end user, technology developer, or system integrator looking to team up with talented challengers, this call will open from April 1st to mid-November 2014. So if you're interested in being part of this unique opportunity, or want to read more about who we are and what we're looking for, don't hesitate to check out our website at www.euroc-project.eu or follow us on Twitter.
So this was a project that we started in 2014. Now we are in stage 2. So we are in a stage in which the 15 qualified challenger teams are experimenting the benchmarking, and now they are engaged into the freestyle, and then they will start working on the showcase, in which they will prepare on a mock-up the end user, the use case, that the 2 best teams for each challenge will be taken to the field test. So, just to recapitulate, we have the first challenge, which is a reconfigurable interactive manufacturing cell. The second challenge is shop floor logistics and manipulation, and the third challenge is plant inspection and servicing. So if we want to, what are the motivations should be quite obvious, because in a way, I think Europe, both as a research community and as an industrial community, has achieved a kind of leadership position in the world scenario of robotics. Also, that we want to be able to just involve what is known as the whole value chain. What I mean by that, the value chain is the research expert in academia, the technology suppliers, which might be either industry or SME, the system integrators, and last but not least, the end users. Remember, this is the time of use case driven research and development work. So this was the main motivation to start a project like this. And just to say a few words about each of the challenge, the first one, in one word, could be identified as the production challenge, or if you wish, human-robot interaction or co-worker. And we take advantage of the infrastructure available at IPA Fraunhofer in Stuttgart. This is the group of Martin Hegele in Stuttgart, in which they have IPA Lab, but more importantly, they have a huge lab facility which is called REinEU2036. REinEU2036 is a big funding from the European Minister of Industry to finance a big lab in which all kinds of robots, European and non-European, are used. So basically the 5 qualified teams have chosen the most suitable robots to carry out their use cases with the support of IPA as well as of other research experts like ourselves, CNRS, LAS, DLR, and IPA itself. The second challenge is the logistic challenge, which is also, the current state of attention about mobile manipulation, because that's where more complex problems occur. And this is not only, because typically if I say logistics, people do not try to embed manipulation into logistics. In one of the sequences in the handbook video, you probably recognized Kiva systems. Kiva systems are the intelligent AGVs, which was a brilliant idea, a brilliant venture by Raffaello D'Andrea, who is now a professor back to ETH in Zurich. And Kiva Systems customers were Amazon, Staples, and in fact Kiva Systems was bought by Amazon in 2014. So now Kiva System Technology is Amazon. But basically that's only logistics, it's only mobile manipulation, it's only the intelligent shelves and also pointing to the workers. That's why with Amazon Prime, you order on internet and the following day the book or the item or the garment or the cloth arrives in your home. But the thing is also that that's done by the human workers, which are facilitated by the Kiva system technology. The idea is to also exploit the potential of manipulation together with mobility. So this is kind of use cases which are being developed in the platform host at the DLR with the support of KUKA Roboter, KUKA Systems, and also CNRS LAS. The third challenge is the most advanced one, and so it's beyond the current level of technology because it's a challenge about services. But services could be very broad, so we limit our attention to those use cases where aerial robotics technology is required. And in this case, the platform host is the flying arena available at ETH in Zurich in the groups of Raffaello D'Andrea and Roland Sigwart in Zurich. And that's where the teams are developing their use cases using the technology provided by Hashtag Ascending Technologies, which is a company, they make Pelican, the quadrotor. It's a spin-off of start company of DLR. You might know that Hashtag has been recently acquired by Intel. So Hashtag is now Intel. And the same story is also happening, this kind of acquires for Alstom Inspection Robotics. Alstom Inspection Robotics was a spin-off of ETH, which is part of the modern company. Alstom is power systems in France. So it was part of the mother company in France. But Alstom Inspection Robotics has been bought since 3 months by General Electric. So now it's General Electric Inspection Robotics. So this is something to think about because the money often comes from the US. So Intel bought Hashtag. General Electric bought Alstom Inspection Robotics. I can give another example. In one of the video clips that you saw autonomous cars. You remember that, autonomous car. You saw Google car, you saw also car in an urban environment. That's the lab of a colleague, a good friend of mine, Alberto Broggi. He's professor of computer science at the University of Parma. And he has a very nice lab, this lab. And he has some really nice technology, bought by Albarella. Albarella is one of the company of X, Google. So at least the technology stays there because, and also the main power stays there. I give another example then. At the DLR, it was also in the video, there's some beautiful surgical robotics technology called MiroSurge. MiroSurge is a patent by DLR, which is a very nice system, which has a much higher potential in terms of the force feedback compared with the Da Vinci system that we also have in our center. Da Vinci is a high resolution 3D vision with immersion, but there is no sense of touch. MiroSurge, I was expecting as European that could be bought by Siemens or even by KUKA. No way. It's not, I know who bought, but I cannot reveal, but it's a US company. So, that's something to think about because that's where, all the big investment and also the entrepreneurial kind of attitude towards the new technology comes from. At least this kind of technology stays in Europe with investors from US, at least. But maybe in a few years it's brought, the technology is brought to India or to China because it's cheaper. Of course. And this, I mean, Franca e Mica, the robot, cost 9,900 euro because it's not made in Augsburg like KUKA robots, but because it's made in China with the design. So, I mean, that's how things go. And of course, robotics is being influenced by this. And this is happening every day. So, this is the service challenge for aero robotics. And this is the way Europe project works. So, as you saw also in the video, we have the 3 challenges. So, right now we are here. We are just about the 2nd stage. And the nice thing, I mean, there's been a lot of word in the media about DARPA Robotic Challenge, that the first prize, if I remember well, was 2 million, the second prize 1.5 million, third prize 1 million. I mean, at the end of the day, we will have distributed 7 million euro to the challengers, and I think this is a nice thing to do for Europe, and perhaps deserves a kind of wider dissemination than the fancy or maybe more sexy things that it's usually European media want to tell the European citizens and also the taxpayers of the money that goes into research. I think we as a community, we should do more to promote ourselves, our technology, because we have excellence here in Europe. And the proof is that the capitals, the investment, they come here to get, the best technology and the best brains. Don't forget, brains is even before the technology. So just a few words about call statistics, and also I shall mention that Europe project is a part of a wider initiative within ICT and Factory of the Future. This initiative is known, you can Google, as I4MS. I4MS stands for I is ICT, for, preposition, manufacturing SMEs. The goal is to beat the bushes of the many small companies in Europe and give them a chance to apply to competitive research with European consortia. So Europe has succeeded in this respect because we have had quite a good number of SMEs as end users, and also SME as technology developer and as system integrator. Those are the statistics from the 3 challenge. So I don't have time to go into details, but I just want to give you a glimpse of what the current 15 challengers are working on. So those are the 5 teams engaged on the production challenge. So the first one is about safe and reconfigurable robot companion for CNC pallets, load and load station. The second one is a classical automotive application with industrial co-workers. The third one is a learning-based approach for robotized coils winding in the electric machine manufacturing industry. The fourth one is Nimbro. It's a flexible energy chain assembly automation with a lightweight cable-driven robot. And the fifth one is EOSmart, reconfigurable assembly serve for highly dexterous and intelligent operations. So those are the 5 teams that have been funded into this stage. In the second challenge, logistics, we have RSAII, flexible robotized unitary picking in collaborative environments for order preparation and distribution center. So it's kind of classical logistics use case. The second one is the one that I mentioned, the Airbus, in which we need mobile manipulation. So joint robot human logistics and assembly in aerospace. The third one is Automap, autonomous mobile manipulation system. And I know this one because this is done in cooperation with CERN in Geneva. We also have a cooperation with them. We're not involved into this experiment, of course, but I know the work because I have some guys, one of my postdocs is currently working there on stage at CERN, and the idea is to kind of robotize some kind of tendering and servicing operation for the collimators around the linear accelerator. The problem there is that's a kind of hostile environment. It's kind of hazardous environment because you typically, when the plant is operating, the technician has, I think, 1 minute time because you have to wear a dosimeter to really measure the level of radiation, and after this you have to leave the area, otherwise you can be nuclearly contaminated. So that's a typical case in which we need this kind of robotics technology. Team Iris is another use case for blank feeding for packaging machines and Nimbro logistics. We have this team from University of Bonn, the team of Sven Benke, who also they took part also to the DARPA Robotic Challenge in the US. They are the masters of competition because they had successful proposals in all 3 challenges. So it's one team engaged with different people, Nimbro, in the 3 challenges. They really like to play, they really like to compete, and they are successful. In the third challenge for services, we have tomb flyers, the Tech University of Munich, vision-based micro aerial vehicles navigation for systematic inspection of structure. There is another one for plant servicing. This one is also very nice because it's inspecting inside and outside the chimney and the smoke pipe, you know, for inspection robots. This is for power substation, and this is for the wind turbines, for the wind generators, in which you can imagine how difficult it is to inspect this with machines. So using the flying technology is the way to go. So just to wrap up, you know, let me try to provide a sort of taxonomy, what in my view are the open problems in manipulation. Logistics is important because that's the kernel of mobile manipulation, because you need mobile vehicles, but also you need this logistics to be transformable and scalable. Except the video, I can leave the slides with you, including the other videos which are public. You know, just I can leave the embedded PowerPoint, but I have to pull out that handbook video for a couple of months. So also, you must have some kind of robust technique to detect and avoid obstacles in 3D. Also, to be able to do the SLAM dynamically. SLAM is simultaneous localization and mapping in dynamic environments, so you have to do this dynamically. And also, you must be able to navigate in narrow production space, because sometimes the shop floor is very cluttered. For instance, the example that I show at CERN is kind of cluttered because there are several technicians do some kind of operation, so there can be like kind of junk, wires, cables on the floor, and so that's why we resort to this kind of aerial technology. And also, you must be able to pick up an object of various shape and size and things like this. But beyond logistics, what is missing is to have a kind of general purpose, I call it even generic manipulation skills, also to solve application-specific, higher-level, value-creating manipulation tasks, and also to do not only the planning of the motion, but the planning must become reactive in such a way as to integrate the online sensing from the environment. And we have the technology, because in the video you saw the nice myself playing the Jedi boat with the KUKA, with the Kinect. Kinect is a very cheap sensor. It's $100, 100 euros. Of course, you can need maybe some depth, so we use the Asus RGB plus depth sensor to do this, but the technology and the cost is very limited. Also to integrate, okay, I said already, to link the visual quality control process intelligently with planning. So planning and control are not two different beasts. It must be integrated. So it's not that you do the planning and then you do the control. I mean, they depend on each other quite tightly. And last but not least, mission instruction, planning and control, intuitive and efficient ways for humans to instruct robots, the difficulty of how to program a mobile manipulator to enable workers to handle basic problems, and also to provide some kind of intuitive interfaces to the warehouse management system to do the task planning as a kind of plug and play. Like our kids, they get a new smartphone, no one reads the instruction manual. You know, they just plug and play with the smartphone. So that's what we want to achieve also with the mobile manipulation. And also, don't forget that this is a complex kinematic system. But also depends if you have what kind of wheels, because if you have omnidirectional wheels, like Castor's wheels, you can move all direction, but also you can have constraints, and you have to deal with, you have to be transparent to the complexity of the kinematics. But of course, the designers must account this, that the system must be actually mobile, you know, and easy to operate. Like, for instance, the piano movers problem of the guys carrying the piano with wheels, you know, so or if you have to go shopping to the supermarket sometime, you know, you get stuck and, you know, just in the corner, things like this. So, of course, you must provide tools to handle this. And safety, human and robot sharing workspaces, because we don't want, I mean, this is not like the unmanned factory. Logistics means in environment also with humans, just walking and like the Fiat plant, which I mentioned. So this leads to a number of industrial requirements, which can be summarized in 5 specs. Setup time, cycle time, dependability, technology readiness, and last but not least, cost. The platform you saw, OmniRobot with KUKA lightweight, it's too expensive, because altogether is almost 200,000 euro. So it's really out of the market, although they've sold a few units, but we need some kind of more less expensive system. And also technology readiness is important, because if you have tried to submit one of the proposals to one of the open calls in Horizon 2020, especially for the innovation action, you must reach a TRL, technology readiness level, of at least 6 or 7. And it's not easy to achieve that kind of level if you're doing research in your lab. You really have to work hand in hand with the industrial stakeholders. Core technology for mobile manipulation. I do this kind of tussle game just to summarize all the ingredients you have to put together: materials, actuation, end effectors, safety, power management, real-time communication, control, locomotion, navigation, sensors, sensing and perception, human-machine interface, planning, learning, system architecture, system engineering tools. And those have to be brought all together to make a successful system for mobile manipulation. So, which concrete technologies and which methods should be used? How to integrate them into complex systems? I mean, I mentioned all the know-how. I mean, mobile manipulation really captures most of the know-how available within the robotics realm. How to achieve reliability? And reliability is important. You don't have to get it to work only in your lab when the TV comes, to just this have to work just, hours and hours, and to be very, very reliable. So clearly, we're not yet there. So, of course, people think about humanoid robots and things like this, but I'm an engineer, and as I mentioned, I have to be with my feet on ground, and I have to say that the mobile manipulation research and development problems, which could be a sort of low level compared to the fancier and sexier kind of social robotics, are not solved yet. To be said that we have a kind of top system working in industrial environment. So, technology combinations, what could be some kind of virtuous combination of technology that might lead us as a research and development community towards achieving successful goal within mobile manipulation. Mobile manipulation human workspace, like systems that can support a human worker with manipulation tasks. I just let you read, but of course, it's the same issue. It's structured and dynamic environments, planning, safety, collaboration, interaction, learning, and adaptation, all brought together, and not to tackle one after the other. And also development of new safety concept. How can we, there's lack of standards. Like the KUKA lightweight robot is known to be safe, but how much safe? We need quantifiable measures for this. Analysis of workspace sharing systems, and also it's very important to match some ergonomics requirement. We have some colleagues in Naples in the Department of Industrial Engineering. They're looking at all the kind of ergonomic requirements, just what kind of worker works in relaxed conditions, because of course it's more productive, and it's like, you can have like a virtual reality room or things like this, and also you can even do collaborative manufacturing using virtual reality tools, to be more ergonomic if you wish. And also, you have to be able to integrate the collaboration interaction, the cognitive abilities, and the sophisticated sensing, which is currently available with the current level of technology. Rapid deployment in industry, and we must be able to deploy this in industrial, realistic environments, because the current development strategy rely on a long setup process only by the experienced system operators, and generally, this kind of development is not yet automated. It needs some kind of training, and this is an investment. It's not plug and play at all. So that's something that should be carefully accounted for. A key will be reducing the time and effort spent by operators in configuring a perception system. Who has worked with visual? It's like all the calibration, all these kind of preparatory steps that have to be made is only for the experts, and it's kind of time consuming. And so people do not want to invest, because it's not just you buy the toy and you can play with it, because you must also invest into the training of your technicians, of your operators. And also, a major step is expected to make more use of learning capabilities. For instance, in the pizza making robot, we have involved a real professional chef, and he is wearing a biokinetic suit made by Xsense, And we are scanning all his, because he is the master of pizza, and so he can make the most dexterous motion for this kind of tossing motion. So this could also overcome some of the barriers in programming and calibrating the system. So really exploit the better learning capabilities. And also the limiting the dependence of costly infrastructure solutions. Also projects like Euroc that I mentioned, and there are other projects funded by the European Union, in which the idea is to create some kind of, in the medium-term goal, is to create some kind of clusters where all the researchers can go and test and try some kind of techniques and algorithms. That's the way to go if we want to impact as a Europe, as like one strong industrial research and development community. I think we have to really gather, because that's our style of doing research compared to the... I was shocked when I was on a US tour. I have to tell you this. I was on a US tour visiting the 15 top labs in North America. I was with the European delegation, okay, of experts. I was people from industry. I was representing academia. And I was shocked. You know, I went to two top universities, one Carnegie Mellon University Robotics Institute and MIT, XAIL, Computer Science and Artificial Intelligence Lab. I was impressed negatively and positively. You know why? Carnegie Mellon Robotics Institute is top institution, PhD in robotics. A lot of friends and colleagues I have there, top guys. Like there are 50 egos, 50 individualists. They ignore one another. And they even talk bad about the work. And they even work on the same kind of topic. Hyper competitive. XAIL, MIT, nice Frank Gehry building, data center, you have to visit in Cambridge. It's architectural, it's very nice. You go there, a different atmosphere. All the PIs, all the scientists, all the professors are sitting at a table, drinking coffee, talking, brainstorming in a very cooperative and it's in a kind of harmonious way. It's maybe because like it's kind of closer to the European system, but those are things you can see. Because in Europe we have different culture of doing research together. And I think we should further exploit this, you know, which is our richness and our potential. I'm really telling you with my heart with the heart in my hand, because I think we have done this, but I think we can even do better, because this is our strength, I think. Robotics 2020 is a multi-annual roadmap effort which for robotics in Europe, and you might have heard about SPARK. SPARK is the public-private partnership initiative between the public side, that is the European Union, and the private side. The private side is EU Robotics, the European Robotics Association. So I'm one of the directors of the board of the European Robotics Association. So I'm also committed because it's an important role. And the nice thing is that membership is at the institutional level. I don't know if Slovak University of Technology is a member of the robotic. If not, I think I really advise you to become a member. You might be already a member. I don't remember all the 280 members, but it's really nice, you know, just to do this, to work all together. So, just the bottom line to wrap up. I leave you with the three messages. Research is important. Integration is important. And challenges and competition are important. So those are, I think, the three foci of interest, I think, which is like the bottom line of my talk, and you can understand why research is important. I think I've extensively discussed it, why integration is important, use standard platforms. We don't have to reinvent the wheel in every lab all the time. Also, we have to combine, it's fine to introduce innovative technologies, but we must be able to combine this innovative technology according to a rigorous systems engineering approach. Not just, you know, to do some kind of fancy results that maybe you can publish in Nature or another journal, but then doesn't work in practice, you know, just like things like this. Safety and dependability are key abilities. Challenges and competitions are important, and in this we are lacking, because we've gone behind the American culture. America is the country of competitiveness. I was shocked when I was a young PhD student in US, and my mentor asked me to give the test to his student because he was on a trip. And I gave the test, and there was two guys that I knew and they were really nice guys. One of them asked me a question: what was the acronym meaning into one of the quiz, one of the questions? I mean, I am a social guy, and then I say, I know that I was a professor, so I asked the other guy, what does this mean? he realizes that I was asking for the other guy, am I supposed to tell you? Gee, I mean, this is really, just is like, and I was sharing the office with 2 other guys. They would close their notes into the drawers because it's like, we live in a different way. Maybe the truth is in between, because sometimes we are too social. And I mean, if I am a professor and I give a test and I go out, everybody copies. And then we know that, that's what happens, I think, in Italy and in Slovak Republic and everywhere. But there, and just because, that's really, really, really extreme. But I think they, the mentality of competitiveness is part of their tissue, of their social tissue. And I think, I want to take the good side, because challenges, competition, drive innovation, better awareness, and also benchmarking is very important. I think I'm pretty much done. I thank you very much indeed for your kind attention. And of course, being in Slovak Republic, I cannot refrain from honoring a great citizen and man of this country who is the captain of Napoli team. I'm speaking about number 17, Marek Hamsik. He is my idol and my good friend. So thank you very much indeed.